So we move forward with the last section, wellness at every level, and it's my pleasure to introduce Matt Fitzgerald, who's going to talk to us about fitness in relation to health and better health. Matt's a New Hampshire native. He's married his passion for sports, fitness, and writing. He's a certified sports nutritionist and consultant, and he is an expert at training plans, and he's going to talk to us about fitness. Matt?
Thank you, Ruth. So I am truly honored and delighted and frankly flabbergasted to be here. I don't think I've ever been in a more remarkable room full of people, and I really mean that. And if you humor me just for a moment, could I get a show of hands? Could you raise your hand if you have an MD or a PhD or both? Now, could you raise your hand if your formal education terminated with a bachelor's degree in English? And finally, raise your hand if you haven't understood a freaking word that the previous presenter said. All right, so be it. One of my, am I allowed to say this? My favorite presentation so far was Jandel's. I really like the distinction that Jandel drew between upstream and downstream. And I'm an upstream guy. So I'm the guy who's trying to beat the crap out of the guy who's throwing people in the river and prevent them from doing it again. So I'm going to give an upstream presentation. You'll find that in addition to being the least educated presenter here, I also have the most primitive PowerPoint skills. I hope you all appreciate that. So here's the question. Do we need a theory of healthy eating? And what I mean by that is it worthwhile to try to identify a basic underlying dietary principle that we can use to guide our eating decisions in a way that maximizes health? Answer, no. So thank you all for your kind attention. If there's any questions, I'd be happy to take them. All right, so cat's out of the bag. This wasn't going to be like a murder mystery or anything. You know my position now. We'll get down to brass tacks. This is a brief overview of the ground we'll cover. I'll first talk about, in my judgment, there are basically two approaches to trying to identify the optimal diet for health. One is what I call a predictive approach, or a theory-based approach. The other would be a heuristic or trial and error approach. And so then we'll move on to discuss what a theory-based diet is. And the theory-based diets are sort of the product of the first approach. And those are really the diets that we're familiar with in the marketplace of diets. Any diet that has a name and a shtick is going to be a theory-based diet, pretty much. And then, I'm against them. So we'll talk about why those diets fall short, and then move on to discuss the product of the heuristic approach to identifying the healthiest diet. And that is what I call agnostic healthy eating. Agnostic healthy eating is my term for when the trial and error approach to discovering the healthiest diet is actually allowed to play out in the real world. Agnostic healthy eating seems to be where we end up. So I'll take a few moments to present that concept, and then for real, I will take questions. Okay, so here are the two basic approaches to defining the healthiest diet. On the left, we have the predictive or inductive. This is really the basic scientific approach to problem solving. It's a three-step process. The first step is basically reduction, but reduction as a tool, good reduction, where you try and identify mechanisms. Basically, you've got your phenomenon, and then you kind of break it down into parts, and you try to identify cause and effect relationships, and then step back and use those observations you've made to formulate a theory or an hypothesis. And then, of course, step three is to test it, to see if your theory is actually correct. So that's the predictive, inductive, scientific approach. The heuristic or trial and error approach to problem solving is basically, if that's the scientific, this is the way nature works. This is the way nature tries to solve problems. And it's really only one step that's repeated over and over and over. You try shit, and it doesn't work, and then you try more shit, and then maybe it works a little better, and eventually you find something that works. Now, with this approach, predictive, you're really, as it relates to diet, what you're trying to do is identify the diet that ought to work best, and then see if it does. If it does, you get a twofer. Not only have you identified the diet that works best, but you also know why it works. With a heuristic approach, you can find the best diet, in principle, and still not know why it works. So if you're curious about that, you still need to go back to kind of the scientific approach to figure out what it is you've actually done. Okay, so I'm just going to give you, I'm going to lay a specific example of a theory-based diet on you. I don't mean to pick on this guy, it's just a good example. Barry Sears is a biochemist who created a diet that was a big hit in the late 90s. It's still out there, the zone diet. You probably all heard of it. So in the early 70s, Barry was exposed to some new research. Not research he did, but research that showed that injecting phospholipids into rabbits reversed atherosclerosis. Easy for me to say. Is there a scientist in the room? Atherosclerosis. And so that is, that's very microscopic. We've got a big problem we're trying to solve, diet. But he's breaking it down. He's doing reduction, breaking it down, seeing how what the potential mechanisms are. So he went from there to a couple of years later, learning a little bit more about research involving eicosanoids, which are derived from phospholipids and have a wide range of important functions in the body. So he really got interested in thinking about, okay, how can we manipulate these compounds in ways that are health enhancing? And he actually tried to take a pharmaceutical approach initially. It didn't pan out all that well. So then he tried to look at a dietary approach to manipulating phospholipids and eicosanoids. And he came up eventually with this zone diet, which was published in a book in 1995, made him a wealthy man. The basic formulation was get 40% of your calories from carbs, 30% from protein, and 30% from fat in every meal. And then in a later iteration, he added an element of essential fatty acid supplementation. So that's kind of the Generation 2 zone diet. And there you have it. So this is a specific example, but almost all of the theory-based diets follow the same form, where you kind of look under the microscope at tiny little things, identify cause and effect relationships, potential mechanisms, and then try and connect that back to diet, because it ends up on your dinner table. It's got to end up at something you're eating. And the connection, the link between these microscopic observations and what's on your dinner plate is usually some kind of simple concept, just some kind of conceptual link. In Freudian psychology, sex is everything. Well, in all of the theory-based diets, something is everything. Something is everything to diet. There's that conceptual link. In the case of the zone diet, it's eicosanoids. It's all about eicosanoids. You need to balance eicosanoids in order to be a healthy person through diet. But other diets use other concepts. There's just a kind of a laundry list of different theory-based diets. And in each one, something is everything. So I know if there's someone who's like a hardcore exponent of the paleo diet in the room, or you're probably going to take issue. I am painting with a broad brush stroke here. So maybe being a little unfair to some of the nuance that exists, but it's my show. I've got the microphone, so I'll do it the way I want. So basically, what these concepts do. So, in say the blood type diet or the raw food diet, food is not healthy because it enhances health. Food is healthy because it minimizes the blood sugar response. Or food is healthy because people have been eating it for 1 million years. So it's not healthy because it helps health. It's healthy because it helps out the conceptual middleman. And then, of course, it's presumed what the theory says is by doing that, through that mechanism, thereby you get the positive health outcomes. You want the health outcomes, but there's an intermediary step where it's all about, say, in the low-calorie diet. Food is healthy because it has a low calorie density. And the low calorie density is what gets you to the better health outcome. So all theories make predictions, right? So this is where the rubber meets the road. When you get to the testing stage of any of these theory-based diets, you take your prediction and hope that it works out. You're rolling the dice, and it unfortunately never does. In none of these cases, in every single case of a familiar theory-based diet, there's a prediction that doesn't work out. So just, again, a couple of laundry list of examples here. Low carbohydrate diets will generally try to predict that high glycemic index diets will promote insulin resistance and weight gain and increase risk for type 2 diabetes. So when that's actually put to the test, it doesn't work out that way. That you can have a high GI diet that is bad for health if it's all Coca-Cola and Smarties, candies. But you can also have a perfectly healthy high glycemic index diet. You know, there are healthy whole foods that have a fruit, for example, not an unhealthy thing. So again, a prediction there doesn't work out. One of the paleo diet predictions is that eating grains, even whole grains, because we didn't eat them presumably a million years ago, except we did, increases chronic disease risk. But in fact, eating whole grains reduces the risk for cardiovascular disease. It even extends lifespan. So again, another prediction that doesn't work out. And then one more example here, vegan diets. Generally, they'll make a prediction that eating meat reduces life expectancy. Eating a lot of meat does reduce life expectancy, but the best and most recent research taking a look at that prediction finds that actually people who eat a little red meat live longer than people who eat none at all. So you get the point. There are other examples I could give, but in each case, there's at least one prediction, usually more, that the theory of the theory-based diet makes that does not pan out. What the heck is this? So why don't these theories pan out? The problem with the inductive approach is that it's not a useful tool for handling complex optimization problems. An optimization problem is basically any problem that can be framed in the form, what is the best way among all conceivable ways for system X to reach desired end state Y? The problem is when there are a lot of conceivable ways to reach that end state, then the theory that you come up with is never going to be better than a wild guess. When you have just a few possibilities, induction can work brilliantly. But there's a threshold beyond which when there's 100 or more conceivable ways that could be the best way, the strange laws of complexity become manifest, and then your theory is basically just a shot in the dark. And that's where the predictive approach kind of falls apart, and it's really not useful to answering the question, what is the healthiest diet, or what is the optimal diet for human health, because that is a complex optimization problem. So this slide comes, the prototypical optimization problem is the survival of living species in natural environments, right? So there, the problem you're trying to solve is death or extinction. You need to adapt to changing environments in order to persist as a living species. That occurs through a trial and error process, which is evolution, natural selection. Now, if you were if you're going to take a species and put it in a changed environment and try to use the inductive approach to identify how that species should evolve in order to adapt to that environment and persist, it wouldn't work very well. Trial and error is what nature does with that problem, and it works exceedingly well. To try and do that, to create a plan, an evolution plan for a species, in a laboratory would not work very well. And in fact, if you're skeptical about that point, there are much, much simpler problems than that the predictive approach utterly fails to be able to do better than trial and error does. And that's where we finally get to this slide here. It comes from a study that was done by a couple evolutionary biologists, Andreas Wagner and his colleague Eric Hayden. And what they did is they took an enzyme and extracted it from a bacterial species. And during lunch, I looked up enzyme on Wikipedia. And so I understand that enzymes, for my fellow English majors in the room, are basically the engines of metabolism. Enzymes catalyze, good word, catalyze reactions that life processes depend on. So this was one enzyme from one bacterium that catalyzed one reaction, had one job. So Hayden and Wagner, they created 1 billion copies of this enzyme. But as in nature, the billion copies weren't perfect. So there were certain switches in amino acids that made mutated versions of this enzyme. So they had 1 billion not exactly matching copies of an enzyme. And then what they did is they tested each one of them to see if it could perform not the reaction it was originally designed for, but a slightly different one. And some of them, none of them did it particularly well, but some actually, just with one generation worth of mutation, were able to sort of make that reaction happen. So they chose those and killed all the other ones. And then they made 1 billion copies of the ones that were able to do the new reaction. They went through 10 generations, and that's all it took. After 10 generations of just selecting randomly mutated enzymes that did a new job, a novel job, a little bit better, they found one that was unimprovable, that did the job absolutely perfectly. Now, that wasn't the biggest surprise. The biggest surprise, I'll just read this. This is a quote from Andreas Wagner's book, Arrival of the Fittest, which I highly recommend. Many researchers have studied the RNA enzyme with which we started our experiment. It is a short molecule with only some 200 amino acids. We know its amino acid sequence, its fold, what it does, and how it does it. We know most of what you might want to know about it, and we precisely controlled the environment in which the enzyme evolved down to the concentration of every molecule for many generations. With this near-perfect knowledge, you might think we should be able to predict how the molecule would change to solve its new task. We didn't. The solution that nature came up with to improve our enzyme was completely unexpected. To this date, we do not fully understand why it works best. One enzyme. Now, the human body produces an estimated 2,709 enzymes that catalyze approximately 896 reactions. So if the inductive approach doesn't work better than trial and error to solve a one enzyme problem, how is it going to work better to solve one that's approximately 2,709 times more complicated? It ain't. It's not going to work. So talking of reduction, I'll just read this one as well. It's from Barry Sears' book, which sold a lot better than Arrival of the Fittest, I'm pretty sure. Enter the Zone. These hormones are among the most powerful and important substances in the body. They act as master switches that control virtually all human body functions. Eicosanoids are so crucial to our health and well-being that I came to think of them as the molecular glue that holds the human body together. I'm not a biochemist, but my understanding is most biochemists would not agree with that, right? I believe it's even a stretch to refer to them as hormones. And they certainly aren't the molecular glue that holds the human body together. So this is bad reduction. And again, I don't mean to, Barry Sears and I follow each other on Twitter. I don't mean him any harm. I'm just using him as an example. So this is what you do, because Barry and other people who create theory-based diets, they're not dumb. They're aware of the fact that when they're trying to identify mechanisms that they can use to make predictions about the best way to eat, they know that they are only able to look at one small piece of a very large and complex puzzle. Their way of working through that is to pretend that their piece is the only one that matters, and the rest is just a bunch of nonsense. So you get examples of very intelligent people like Barry just exaggerating the importance of eicosanoids. And again, that's just one example, but they all kind of do that in some way. It's like Freud. Everything is sex. Trust me, everything. Nothing is everything. Okay, so I've utterly demolished the predictive approach to identifying the optimal diet for health. Now, the Achilles heel of that approach is that it doesn't deal well with complexity. The Achilles heel of the heuristic or trial and error approach is that it's slow. So, think about it. If you have no idea what works and you're just trying things without even postulating, you just try whatever, probably not going to work, right? So then you have to try something else, and that also is probably not going to work. It could take forever. So if we're trying to solve a problem such as the best way to eat, if we started at 0, it could take generations and generations and generations to find the best way to eat. Fortunately, my understanding is that humans have been eating for a while already. So we're not starting at 0. So, odds are pretty good that somebody out in the world is already eating in about the healthiest way possible. How do we find them? That would be very, very helpful to find these people. Well, here's something I'm pretty sure we do know, that what you eat matters to your health. So if eating in the best possible way, if that is the case, eating in the best, healthiest possible way ought to make the healthiest people, right? So we could find the healthiest people, and if we're right about the importance of diet, what they're eating should be a blueprint for the healthiest way to eat. Now, if we don't find any pattern, if we find that the healthiest people eat all kinds of different ways, I guess our answer is anything goes. But if we find that there are consistent patterns among the healthiest people in terms of how they eat, and it's different from how people who are less healthy eat, now we're on to something. That seems like an approach that's worth trying. And fortunately, I believe that this trial and error experiment has played out to the point of optimization in the real world. So it's just a matter of finding those people and finding out what they eat. So here's the step one is we kind of have to define health, right? If we're trying to find the healthiest people, we need to know what we're looking for. Now, our host, Larry, he might be able to suggest a better way to do this, but this is one way we could do it. In medicine, all too often, we define health negatively, right, as the absence of disease or low disease risk. And that's clearly a component of health. My focus, just because of the world I'm in, is on the positive component of defining health, which is, I call it high functional capacity. In order to be truly healthy, in my view, the various organs and systems of your body need to be functioning at high capacity. So, if you're in that state, you're very far from dead. You're very, very alive, and not just free of disease. So what we could do, in principle, this wouldn't be hard at all. We could just create a battery of familiar medical tests, diagnostic tests, some of which would identify high functional capacity in organs and systems, others of which would identify absence of disease or low disease risk. We could quibble about exactly how many tests. If we're trying to create a general picture, like a health score, how many tests, exactly which tests. This is just a few examples of tests that we might include if we wanted to create a protocol where we could just tell someone after undergoing these tests, your health is an 87. Congratulations, you live forever. And so that would be one way to do it. The Stroop test, the last one for people who don't know it, because brain health is incredibly important to overall health. So a Stroop test is like a psychological test that assesses one aspect of brain health. So what I propose is that this is where the trial and error process, let me back up actually before I say this. Now imagine we had this general health score, and not only did we use it to conduct epidemiological research or even in a clinical environment to tell people how healthy they are, but imagine we actually made a contest out of it. So there's like an annual health Olympics where the people who score the highest, who get the highest general health scores, get tremendously large cash prizes. And cool, huh? So, and then we do this every year. What's going to happen? You're going to get people not so much gaming the system, but training for it, right? Preparing. It's like if grand prize is $1 million, someone who's already pretty healthy is going to be like, I could win that. So over time, you're going to get an evolution in the methods that people use to train to win the health Olympics. So anything that could conceivably help you score better on one of those tests, you're going to maybe sleep more, right? Work on your stress management a little bit. And then maybe the big ones are going to be exercise and diet. So over time, the guy who wins the health Olympics, the gal who wins, is going to be emulated. People are going to look at the methods that that person used to win the $1 million, and next year, they're going to use those methods, right? So we've got a trial and error process where over time, we'll eventually get people who have unimprovable methods of increasing their overall health. And it can't go on forever. It's not like iPhones that'll just get better and better until they solve all of our problems. And basically, it's heaven on earth thanks to iPhones. You know, there's going to be a ceiling until we evolve beyond our current species. There will be a limit to what we can do to increase our health. Well, my suggestion is that elite endurance sports are the health Olympics. Now, again, if you're skeptical of that, I will try to correct that problem. So, so I'm biased. As my brother likes to say, it's a Buddhist expression, the farmer points the way with a radish. So I am an endurance athlete. I'm surrounded by endurance athletes. Surprise, I think endurance athletes are the healthiest people on the planet. But I can prove it. So there's actually a tremendous overlap, almost a complete overlap between the physiological substrates of general health and the physiological substrates of endurance fitness. They're almost the same thing. Anything that you need physiologically to be healthy, you need even more of to be an elite endurance athlete. So I think of endurance fitness as a sort of intensified general health. Just take something like, to be a generally healthy person, you need a strong endogenous antioxidant defense system. You need that in order to prevent cellular wear and tear and to kind of slow the aging process. Well, an elite endurance athlete needs an even stronger endogenous antioxidant defense system to prevent muscle damage and the fatiguing effects of oxidative stress that occur during exercise. You need it, and you just need more of it. Take something like insulin sensitivity. The average man on the street needs a high level of insulin sensitivity in muscle tissue in order to prevent hyperglycemia, the fallout from that over time to prevent type 2 diabetes. Well, an elite endurance athlete needs an even higher level of insulin sensitivity in muscle tissue in order to be able to metabolize muscle fuels at a high rate during competition and also to recover faster after intense training. So everything you need a little more of to be an elite endurance athlete. So what I'd like to suggest is that, well, again, let me back up. So how do elite endurance athletes get this very high level of general health and endurance fitness that they have? Obviously, some of it comes from genetics. These people are genetic lottery winners. They're born with a high baseline level of general health and fitness. They're born with like a very low body fat percentage, right? And you need that to be efficient on the race course. You also need it to live a long life. So that's part of it. Genes is part of it. Training is clearly another big part of it. That's a big way of raising the baseline. Aerobic exercise this is pretty well proven, is known to enhance the functioning of virtually every organ and system in the body, including the brain, and in fact, most especially the brain. The brain actually adapts to aerobic exercise more profoundly than any other organ of the body. You remember the Stroop test that I mentioned before, the psychological test that you can use to assess brain health? People who are aerobically trained crush the Stroop test for brain function. So there goes the myth of the dumb jock. So then the third piece besides genes and training would be diet, right? Diet is critical to increasing general health and endurance fitness because it's the same thing. So back to this slide. I would like to propose that both elite endurance sports and evolution in the natural world are self-organizing systems. And a self-organizing system is basically any system that is structured in such a way that it automatically moves towards the optimal solution to whatever problem that defines it. And let's actually start on the right here. So for living species in the real world, again, the defining problem is survival, persistence. And you need three things to qualify as a self-organizing system that self-optimizes. The first one, you know all this. This is the non-scientist teaching the scientists extremely basic Darwinian principles, but let me do it. There was one English major in the room up here, wasn't there? I'm talking to you. the first one is variation, right? Variation. So in species, variation is at the level of traits. That's where it matters. So you have a population and they have different traits, and some of them confer a higher level of fitness than others do. And so the idea is that you have a better chance of surviving and procreating if you possess traits that are that make you well adapted or fit for your environment. Requirement number 2 is selection. You need some mechanism that unflinchingly distinguishes good traits from bad traits. And in evolution, the selection mechanism is death and procreation. So traits that make you well adapted to your environment, you tend to live longer, you tend to have more children, you pass them on. Traits that get you killed young, prevent you from procreating, and then eventually those traits are kind of weeded out from the species. And then the third requirement for a self-organizing system is replication. You can't evolve much in one generation, right? Think about the antelope-like species that giraffes used to be, short neck. Well, you didn't get from a short-necked antelope to a long-necked giraffe in one generation. It took generation after generation. So again, I said trial and error is slow, but time moves on, and eventually you've got enough time for big changes to occur. So with these 3 characteristics, living species will automatically become optimally adapted to whatever their environment is. That doesn't mean that all species can evolve and to survive in all circumstances, but it means that you'll do the best you can if you have these 3 requirements. Move over to the left side here. Endurance sports has all 3 as well. So I'm talking about elite level endurance sports where if you don't win a race for 1 year, you lose your job, you lose your sponsor, and you're back to flipping burgers. So variation in elite endurance sports occurs at the level of training methods and dietary practices. There are other things too, equipment, whatever, but we'll just focus on training and diet. So you've got, trust me, different athletes use different methods. They have different diets. So you've got plenty of variation. Selection occurs at the Olympics, at the Tour de France, at the Boston Marathon. If you win one of those races, it's very likely that the guys who finish behind you, the gals that finish behind you, are going to, in as much as their diet and training methods were different, they're going to abandon those, copy yours, and next year give you a run for your money. And again, you can't expect training methods or dietary practices to change much from the 1986 Boston Marathon to the 1987, but guess what? Boston Marathon has existed since 1897, so that's a lot of time, a lot of replication, a lot of opportunity for these methods to get better and better and better until they can't get any better. So that's why you see the way these endurance sports are structured, it's very much like that general health score contest I hypothetically threw out earlier, where there's the incentive for people to do it as well as they possibly can, and given enough time in the structure of the sport, it's inevitable that we will get to the point where we have unimprovable methods, and we're focused on diet. It's interesting, training is a lot easier to quantify, and there's a very interesting researcher named Stephen Seiler who he quantified how elite endurance athletes train. And he found that all endurance athletes, from rowing to cross-country skiing to triathlon to swimming, you name it, everywhere in the world, from Australia to Canada, train essentially the same way. They do 80% of their training at low intensity, 20% at high intensity, and they had no idea they were doing it. In 1897, at the time of the first Boston Marathon, that wasn't true at all. So again, this isn't inductive science. We're looking at correlations and associations, but often where there's smoke and there's fire, and one of the best signs that you have a self-optimizing system on your hands or self-organizing system is convergent evolution, where you see an initial state where everyone's all over the place, and then over time, it all comes together, and again, blindly, without people even realizing that they're starting to do the same thing, they end up all doing the same thing. When I learned about Stephen Seiler's research, I thought, that's very interesting. I wonder if the same thing occurs at the level of diet, right? You know, Seiler sort of proved it happened. We've seen convergent evolution in training methods. If I'm right that elite endurance sports are a self-organizing system, we should also see it, unless diet just doesn't matter, which it does, then we should see the same thing on the level of diet. So a part of my job, and a part I like, is studying the diets of elite endurance athletes. I've spent about 20 years doing it, but only within the past 6 or 7, I've been doing it quite rigorously. The great thing about being a non-scientist is that you can do crappy science and not feel guilty about it. So that's what I do. I do crappy science and I don't feel guilty about it. So what I do is, you know, I try to apply a certain level of rigor to this enterprise, but I'm just trying to identify patterns in the diets of elite endurance athletes. So I'm actually working on a book now that is really focused on this, just trying to identify common patterns like that 80-20 intensity balance on the training side. Is, you know, what is the equivalent on the diet side? So actually, I just got here. I just flew in from, and boy, are my arms tired, from Canada. I was up in Canmore near Calgary, hanging out with members of the Canadian national cross-country ski team. And I literally knocked on one of their doors at dawn and dragged him out of bed and said, "Show me your breakfast." And he obliged because he's Canadian. He's like, "Hey, hey, hey." And he had great coffee. So yeah, that's what I do. Earlier in the year, I was in Spain at a training camp for a Dutch cycling team, one of the teams that's going to be in the Tour de France. Actually, they're in the Tour of California right now, the Lotto Jumbo team, watching them eat. I'm going to Kenya at the end of June. I was telling Claudia about this earlier. I'll be in Kenya hanging out. I hear they've got some good runners in Kenya. I'll believe it when I see it. Yeah, I'll be eating with Kenyan runners. It's a lot of fun, and you know, it's crappy science, but I'm convincing myself of what I'm seeing, that these patterns really do exist. And I've also gone back through history and looked at the diets of elite endurance athletes of past generations. And I wanted to find this conclusion anyway, so we need a real scientist to eventually validate it, but what I have observed is that 5, 6, 7 generations of elite endurance athletes ago, their diets really were kind of all over the place, just the way the training practices were. But today, there is a core set of shared dietary practices that, you know, the elite Kenyan runners are on a fundamental level doing the same thing as elite Canadian cross-country skiers. Now, if you look at the superficial level of specific food choices, of course, you don't see that. Kenyans eat ugali 3 times a day. Canadians don't eat any ugali. They do not know what it is. But ugali is it's cornmeal, basically. So it's a whole grain, and it's a high-carb food. Guess what? Elite endurance athletes everywhere eat whole grains and basically have high-carb diets. So this is just a random example. You guys have had plenty of time to study it while I was blabbing. But so you might not see that diet doesn't look identical to that, but the patterns, the core patterns that are underneath the specific food choices are there. So that's Lawrence Pendam, one of the cyclists I spent time with. And the other thing I'm doing, because I can't travel everywhere, can't afford to yet. So what I do is I've created a questionnaire that I send out to athletes. So I've created sort of a database where these athletes are really very generous with their time, typically. So I found a Saudi Arabian Olympic swimmer who filled out my questionnaire for me, so it added to the database. So those are 2 examples. The patterns that are underlying those examples like that are here. So these are the basic characteristics I've found. There are others that I didn't want to muddy the waters with, but number 1 is it's kind of a nameless, shtick-free diet. If I ask an elite endurance athlete, what's your diet called? The answer will be like, food diet? It's like, that's about it. There's no shtick, there's no name. It's a very inclusive and varied and balanced way of eating. There are no forbidden foods. They eat everything, but they don't eat equal amounts of everything. It's culturally normal. So the patterns are there, but the differences are on the level of culture. So, Kenyan runners eat like Kenyans. Canadian cross-country skiers eat like Canadians. So all of their diets are based in where they're from. obviously, whatever this optimal diet is, it's not just one country's food. Now, I mentioned that they eat everything, but they don't eat equal amounts of everything. Their diets are dominated by whole natural food types, and the way I categorize them is vegetables, which includes legumes, fruits, nuts, seeds, healthy oils, whole grains, fish, unprocessed meat, dairy. I have found very, very, very few endurance athletes, elite endurance athletes, who does not eat any one of those food types. I think maybe 2% are vegetarians. And 0% are on the paleo diet, unless you consider elite ultra runners elite athletes, which I don't. So, but they're into the paleo diet. And then they have they don't eat much of the refined grains, processed meat, sweets, or fried foods, what I call low quality food types. And my name for this, you add it all up, is agnostic healthy eating. So that is basically what we're seeing elite endurance athletes do. Now, if you look back at this, you might have studied it and said, there's nothing special about that. It's just a normal diet. And it is, in a fundamental way, it is normal. But trust me, it is a special diet. Almost nobody else actually eats like that. At the risk of annoying our host, yesterday for lunch, I had a sandwich on white bread, low-quality food, accompanied that with potato chips, fried food, another low-quality food. I've had a lot of great food here, and I know I'm going to have more, but and I chose to eat it. There was a salad. And guess what else was in the box? Cookie, sweet, and there was a table full of, I really draw the line at Coke, right? Yeah, but it was either water or another sweet. So that's normal. That is how people eat. You look at these diets, none of that is in there. Just a very, very, very little bit of it. So it's all the high-quality foods, none of the low-quality foods. So it is a special diet. Also, if you go back again, 5 or 6 generations, people weren't eating quite like this. There has been an evolution and a convergence. Also, elite endurance athletes don't grow up eating this way. They grow up eating culturally normal diets. And what happens is when they get to the level, and they crush everyone because they've got the genes, right? They crush everyone in competition from the day they start their sport until the day they graduate college. Then they become pro, then they're competing against the best in the world, and then they start to get their butts handed to them. And that's the point where you see them make targeted changes to their diet that simply amount to copycatting the guy who's beating them in workouts and races. And it's usually not a big change. It's not an overhaul. They maintain that culturally normal basis, but they just, whatever they're not doing, that the guy who's winning the race is doing. So what happened is, this agnostic healthy eating approach evolved over generations. And now that it exists, it's just passed on to the next generation coming up over and over again. So that is agnostic healthy eating. Now, why might you consider eating like the guy who wins Ironman? A few reasons. Well, when I give this shtick to, I just called it a shtick, which is ironic. When I give this sound information and final solution to athletes, a lot of them will say, well, elite athletes, I have nothing in common with them. Like, they're working out 4 hours a day. They can get away with eating whatever they want. The mistake there is you're making the assumption that the goal is to look good naked, okay? And I admit, if you work out 4 hours a day, you can eat McDonald's 3 times a day and look good naked. That's not what these people are trying to do. They're trying to do something much, much harder than that, which is to win gold medals in the Olympics. You can't get away with slack. So things that look like slack, like a lot of calories, a lot of carbs, are actually musts. They're things that they have to do. Now, if you wanted to eat like an Olympic athlete, obviously you have to scale, right? I'm a runner. I don't run 120 miles a week like the professionals do, so I scale the training to what I'm able to handle. Same thing with diet. You can eat like they do and just recognize the fact that you're not working out 4 hours a day like they are. What's interesting is now, for the hard scientists in the room, and I saw 1 or 2 hands go up when I asked if there were any PhDs or MDs. So, for those of you, you're grumbling, you're saying, well, that's not science. You haven't, it's tantalizing. You've got something, there's a pattern there, but you haven't proved anything. And I totally agree. But we're working on that. Actually, you're working on that. So there's some interesting new, has anyone heard of the Dietary Patterns Methods Project? I'm really excited about it. So it's just kind of a consortium of researchers who are looking basically they're doing epidemiological research looking at the association between agnostic healthy eating, as I call it. They're looking at basically the same patterns and health outcomes and finding that people who eat this way, who eat everything, but eat mostly the high quality foods, not so much of the low quality foods, they are living longer. They're having lower risk of various chronic diseases. And this is a general population, it's non-athletes. So we're starting to get some real science showing that this way of eating that sort of evolved in this crucible of elite competition also really does work for a general population of non-athletes. Another thing is, like, I'm a big believer. I work as a sports nutritionist one-on-one with athletes who need help with their diet. And I tell them over and over that the goal is not just to eat healthy food, it's to have a healthy relationship with food. If you don't have both, you're really not healthy yet. You're really not there yet. Most of the people who come to me, their diet looks pretty good on paper, but they don't have that healthy relationship. If you don't love your diet, it ain't gonna last, and it's just not gonna get you where you wanna go. And elite endurance athletes are very comfortable with the way they eat. It's not work for them, and part of the reason is they're not doing the shtickery. They're not like eliminating food groups. They're not, almost every popular diet or theory-based diet says, start over. I don't care what you were doing before, like we've got the answer, it's one size fits all, and good luck to you. That's not what these people are doing. The Kenyans are still eating like Kenyans, the Canadians like Canadians, they're just raising their quality standards, which makes it more sustainable and more comfortable for them. And then finally, the other reason to eat like the guy who wins Ironman is that you're not that different from him. At least you shouldn't be that different. We all know the expression, you are what you eat, but it's really not true. You are what your body does with what you eat. And what your body does with what you eat is heavily influenced by what you do with your body. So two people who have exactly the same diet, one never leaves his lazy boy, the other exercises vigorously daily, that same diet is going to affect those two bodies in completely different ways. And it's well established that you can't attain the highest level of health without vigorous daily exercise. And what agnostic healthy eating really is, fundamentally, is the diet that maximizes the benefits of aerobic exercise. That's what that diet is doing. So eat it. Now, again, one last reminder. I know I'm beating a dead horse. English major, bachelor's degree in English. So I'm only accepting easy questions. And this.
Thank you. Thanks, Matt. I don't think any of us think, is this on? That your research isn't important. Larry?
I have two short questions. One is based on Yvonne's talk. Do you know elite endurance athletes who regularly take Cialis for health reasons? Just say yes or no.
No.
Thank you. Okay. The real question is, what do you mentioned genotype once, the genes with that. Do you think that athletes, like all other winners, I think Pavarotti has a mutation in his throat. Okay, I believe that. Do you think that is there any evidence for athletes having genes that are helping them be elite winning athletes?
Yeah. So I mean, a lot of the genes that predispose people to perform well in endurance sports, they're kind of two sets. There's like built-in fitness, and then there's trainability. They're two slightly different things. There are genes for both, and they do exist. It's not a huge list. It may get longer, and at least the experts I've talked to, the geneticists who are interested in this problem, they assure me there is no single gene that is essential to greatness in endurance sports. That you can get to the mountaintop by different paths. You have to have some of the requisite genes, but some of them are trainability genes. Interestingly, trainability is much more broadly spread throughout the population. So a lot of us are just as trainable as the Olympians, but we don't have the built-in level of fitness that they have. And I should add, none of these genes that make the great athletes great has anything to do with how food is digested or metabolized. And that's another reason that their diet can also work for us.
So I'm a teacher, and I'd like to ask you, if you've already asked a question, to let somebody else. I think it's back up there.
In your opinion, what is the best food to use for recovery after vigorous exercise?
Now, I don't know if you already know this, and that's why you asked, but there was just recently a study done, published, I don't know if you saw it, finding that a fast food meal performed just as well in accelerating post-exercise recovery as a supplement designed specifically for that purpose. And that's actually not all that surprising. Like, what's more important than what is when after exercise for recovery? You just need calories, and they should be mostly carbs, and protein needs to be in there. A little fat doesn't hurt either. But it's the supplements that usually get the research done about them, but it seems that almost anything will do. During exercise, it's different. Like those of us who love our natural whole foods, like don't eat broccoli while you're running a marathon. There's a time and a place for sugar water. But it seems like, as soon as you finish the workout, I prefer to tell people to go straight back to those whole natural foods, and it doesn't seem to matter all that much. You need enough, you need carbs, you need protein.
What are your thoughts on this gluten-free trend?
I'm just trying to think of what chapter that is in diet cults. 7 or 8. It's called Escape Gluten is the title of that chapter. But that's my shtick on it. But I actually, in that chapter, I talk about the gluten hysteria, and I put it in a historical context. And I call them scapegoat nutrients. They've come and gone. I actually had a cartoon created. There's cartoons in diet cults. I had a cartoon created to make the point. And it shows, it's like outside the state capitol building or whatever, and there's a time capsule that's been dug up, and someone's like looking in, so it's like 50 years in the future, someone's digging up a time capsule at City Hall, and out comes a bag of gluten-free pancake mix, and someone asks, "What's that?" And the person holding it says, "I have no idea." So 50 years from now, I have no gluten-free? What the hell is that?
Last question.
First, I'd like to defend Freud and say that sex is everything. Putting that aside, athletes eat to run and they eat a lot of calories. There's no evidence that this is actually healthy. Actually, being an athlete is a futile exercise because humanity is not designed to be Ironmen. Can you comment on that?
Yeah, something I forgot to mention. Like that whole presentation would come down like a house of cards if it weren't a fact that elite endurance athletes on average live 6 years longer than the non-athletes who are healthy in their 20s. So it's the fountain of youth. Not only, I'm not too big on longevity. As I like to say, I'm trying to add life to my years, not years to my life. And honestly, let me complete my answer to your question this way. I don't know how many other people in the room are like hardcore exercisers or athletes, but I am. And I will tell, I don't do it for my health. I do it for a lot of other reasons. Health is just a side benefit. I'm good at it. Everyone's a sucker for something they're good at. But I wasn't good at anything else. That also narrows it. But my favorite benefit of the 2 hours of exercise I do every day is how it makes me feel. I'm 44 years old now, and I just feel great. Like pretty much all day, every day, I just feel super healthy. And you can't be super healthy without feeling it. And that's life to me. So, every now and then, like someone who really wants it to be proven that running kills you comes out with a study proving that running kills you, and I don't even blink. I'm like, couldn't care less. I feel great today. I'm pretty sure I'm going to feel great tomorrow.
Thank you.